Um, let's do this random rant where I'm gonna just go and visit random Wikipedia pages and maybe just review the content of these pages. Um, and the trick is kind of like just trying to loop from one page to another page without typing anything or searching anything. And I'm just gonna start with some random Wikipedia page. So, um, so, um, so, yeah, this is the Wikipedia page, and let's use this random article. What's today's article? Colombia at the Paralympics. Interesting. Colombia made its Paralympic Games debut at the 1976 Summer Paralympics in Toronto. Okay, so let's see what exactly is Paralympic Games. Also known as the Game of the Paralympiad, is a periodic series of international multi-sport events involving athletes with a range of physical disabilities, including impaired muscle power, impaired passive range of movement, limb deficiency, leg length difference, and different disabilities. I think it was just kind of great, right? I mean, just empowering people to strive for excellence. Isn't that's what it is? Like overlooking their own disabilities, whatever that mean, and trying to do better. And uh, this is sort of celebration of that betterment, I guess. So I mean, I've seen a few games here and there as a kid, um, but it's oh, what happened to the page here? Wait, what? All of this play. I think there's something wrong with browser. Alright, let's pick up some other page. Yeah. Okay, so let's do this. Let me figure this out. What's going on? I am uh, creating a new session, and let's get back to that article. Wait, no, it's not displaying the article or the page itself. What is going on, OBS? I thought OBS was no BS, but this is strange. Technology, you failed me. Why are you failing me? Okay, so it seems to be working in the preview, but once I make it an active screen, it's just blanking out. Why? I might have to download a new. I might have to check the upgrade for this software and figure out what's going on here. But isn't it strange when technology kind of fails you? I mean, I kind of grew up in the time when technology failed me all the time. I remember working through a very shitty desktop at the time, and I remember playing with like all the outdated or what we now call all the outdated technology. But at the time, that was the technology, and how slow it could be, how many times it could error out. Um, it's not a new phenomena, so to speak, for me at least. Uh, but at the same time, um, I got used to expecting higher. Uh, okay. Well, wait. I gotta. I gotta resize it. Cool. Cool. Okay, we are almost there. We are almost there. Ooh, yeah. Cool. There you go. Now we're talking. Let's go back to random article. I am hoping that it will take us to the same Paralympic article. Uh, let's see. That's a good test actually. If it's gonna just randomize every single time anyone does it, and which is exactly what it does. Tuamorka Agon. I'm hoping I pronounced it right. I have no idea how to pronounce that. Uh, Swedish. Swedish, officially the Kingdom of Sweden, is a Nordic country in northern Europe. It borders Norway to the west and north, Finland to the east, and is connected to Denmark in the southwest by a bridge tunnel across the Oresund Strait. Okay. Sweden is the largest country in Northern Europe, the third largest country in the European Union, and the fifth largest country in Europe. The capital and largest city is Stockholm. Sweden has a total population of 10.4 million, the largest of the Nordic countries, and a low population density of 25.5 inhabitants per square kilometer. 87% of Swedes live in urban areas, which cover 1.5% of the entire land area, which makes sense, which is pretty much the trend across the world. Everyone want to move into urban area, and for a good reason. There are a lot of opportunities. There are a lot of, I would say, uh, the urban areas are more lively. Uh, uh, if you are more into like different kind of activities and whatnot. Uh, let's scroll through some of these things. History. Sweden's prehistory began in Ellerod Oscillation, a warm period around 12,000 BC. Huh? Interesting. Okay, so let's see. Was a warm and moist global interstadial that occurred 13,900 to 12,900 BP. What is BP? Nearly at the end of the last glacial period. It raised temperatures in the Nordic Atlantic region to almost present day levels before they declined again in the succeeding glacial younger Dryas, which was followed by the present warm Holocene. First, let's see what BP is. Before present. Okay. So BP is not bad way to calculate history. BP is years before present, is a time scale used mainly in archaeology, geology, and other scientific disciplines to specify when events occurred before the origin of practical radiocarbon dating in the 1950s, because the present time changes. Standard practice is to use 1st January 1950 as the commencement date of the age scale. The abbreviation BP has been interpreted retrospectively as before physics, which refers to the time before nuclear weapons testing artificially altered the proportion of the carbon isotopes in the atmosphere, making carbon dating after that time likely to be unreliable. In a convention that is not always observed, many sources restrict the use of BP dates to those produced with radiocarbon dating. The alternative notation RCYBP is explicitly radiocarbon years before present. It's fascinating how we all kind of like leave a trail even after we're gone. The trail of carbons, which could be dated years into future. I mean, to a certain degree, that's that that's part of you, which is gonna be part of the nature, I guess. Unless you kind of like cremate it and then spread your ash. I don't know if anyone can even sort out ash in all the what do you call the reality, I guess. I mean, it's easier to find bones than ash. So, and on top of that, even if someone was able to trace down some ash, I don't know if they can carbon date that ash, because I would assume that ash is completely burnt, so it burnt all the chemicals within that. So I don't know if anyone can carbon date that. Um, the BP scale is sometimes used for dates established by means other than radiocarbon dating, such as stratigraphy, which is a branch of geology. Stratigraphy. I think I'm pronouncing it right. So it's a branch of geology concerned with the study of rock layers and layering, stratification. It is primarily used in the study of sedimentary and layered volcanic rocks. Stratigraphy has two related subfields: lithostratigraphy, which is lithologic stratigraphy, and biostratigraphy, which is biologic stratigraphy. What is litholic? I can't copy paste, but I'm kind of curious. What exactly litholic mean? Study of rocks. And what is, well, Okay, biostratigraphy is a branch of stratigraphy which focuses on correlating and assigning relative ages of rock strata by using the fossil assemblages assemblages contained within them. Okay, so basically this is just rock dating the rocks and the metal and all the other things, and this is dating the fossils. Hmm. Magnetostratigraphy, okay, is a chronostratigraphic technique used to date sedimentary and volcanic sequences. The method works by collecting oriented samples at measured intervals throughout a section. The samples are analyzed to determine which tetrial remnant magnetism, that is, the polarity of Earth's magnetic field at the time a stratum was deposited. For sedimentary rock, this is possible because as they fall through water column, very fine grained magnetic minerals behave like tiny compasses, orienting themselves with Earth's magnetic field. Upon burial, that orientation is preserved. For volcanic rocks, magnetic minerals, which form in the melt, orient themselves with the ambient magnetic field and are fixed in place upon crystallization of the lava. Whew. That is mind blowing. I mean, um, if I understood it properly, then as the lava was cooling down, there were different minerals, or not minerals, but metals, which started acting as tiny compasses, and those aligned with the magnetic field of the earth. And because lava is sort of um, in a molten form, the magnetic the the the, the metals within the lava were not oriented in the same direction. I think like it was in um, different directions. So based on that, they can calculate the Earth's magnetic field at the time those uh, lava cooled down. I mean, it makes sense in my head. Hopefully, um, I paraphrased it correctly, but let's see. Oriented paleomagnetic core samples are collected in the field. Mudstones, siltstones, and very fine grained sandstones are the preferred lithologies because the magnetic grains are finer and more likely to orient with the ambient field during deposition. If the ancient magnetic field were oriented similar to today's field, north magnetic pole near the north rational pole, the strata would retain a normal polarity. If the data indicate that the north magnetic pole were near the south rotational pole, the strata would exhibit reverse polarity. Alright, so we know what north magnetic pole is, which is a point on the surface of Earth's north hemisphere at which the planet's magnetic field points vertically downward. There is only one location where this occurs, near the geographic North Pole, the geomagnetic North Pole, a related point. So, what is North Rotational Pole? The North Pole, also known as geographic North Pole or terrestrial North Pole, is the point in the northern hemisphere where the Earth's axis of rotation meets its surface. It is called the true North Pole to distinguish from the magnetic North Pole. Okay, true North Pole, distinguished from the magnetic North Pole. The North Pole is by definition the northernmost point on the Earth, lying diametrically opposite to South Pole. It defines geodetic, geo, geodetic, geodetic, geodetic latitude 90 degrees north, as well as the direction of true north. At the North Pole, all directions point south. All lines of longitude coverage there. Oh, not coverage, converge there. So its longitude can be defined by, okay, I mean, it's just describing North Pole, but what was the difference between North Pole and, I don't want to go back, but let's see. Let's see, what was that? North magnetic pole, and this is rotational pole. Okay, so magnetic North Pole. The North magnetic pole is a point on surface of Earth's northern hemisphere at which the planet's magnetic field points vertically downward. Okay. Planet's magnetic field is important, all right? In other words, if a magnetic compass needle is allowed to rotate in 3 dimensions, it will point straight down. There is only one location where this occurs, near but distinct from the geographic North Pole, the geomagnetic North Pole. A related point is the pole of an ideal dipole model of the Earth's magnetic field that most closely fits the Earth's actual magnetic field. The dipole model of the Earth's magnetic field is a first-order approximation of the rather complex true Earth's magnetic field. Due to effects of the interplanetary magnetic field and the solar wind, the dipole model is particularly inaccurate at high L shells. Maybe, but maybe a good approximation. Okay. So how does this magnetic field generate? Let's dive into that, but I'm kind of curious about this history. Early European navigators, cartographers, and scientists believed that compass needles were attracted to a hypothetical magnetic island somewhere in the far north called Rups Nigra. The Rups Nigra, a phantom island, is believed to be a 33-mile wide black rock located at the magnetic North Pole or at the North Pole itself. It purportedly explains why all compasses point to this location. The idea comes from a lost work title, Inventio Fortuna, and the island feature, whatever. Okay. Yeah, kind of crazy how in the past people used to just sort of assign everything to some sort of mystery. But I mean, could a magnetic island exist? What does that even mean? I mean, first of all, I haven't seen any land made out of magnet. I'm not even sure how magnets are made. That would be an interesting topic. I hope like someday randomly we can land on magnets. I think we can go there. Planet's magnetic field. All right, let's do that. Earth's magnetic field, also known as geomagnetic field, is the magnetic field. A magnetic field is a vector field that describes the magnetic influence on moving electric charges. electric currents, and magnetic material. A moving charge in a magnetic field experiences a force perpendicular to its own velocity and to the magnetic field. Okay. Um, but this Earth's magnetic field extends from Earth's interior out into space, where it interacts with the solar wind, and that's what gives auroras. Um, a stream of charged particles emanates from the sun. The magnetic field is generated by electric currents due to the motion of convection currents of a mixture of molten iron and nickel in Earth's outer core. These convection currents are caused by heat escaping from the core, a natural process called geodynamo. That is a very solid name. Geodynamo. In physics, the dynamo theory proposes a mechanism by which a celestial body, such as Earth or a star, generates a magnetic field. The dynamo theory describes the process through which a rotating, convecting, and electrically conducting fluid can maintain a magnetic field over astronomically high, I would assume, whatever. Uh, okay, so it's a dynamo theory proposes a mechanism by which a celestial body such as Earth or a star generates a magnetic field. The dynamo theory describes the process through which a rotating, convecting, and electrically conducting fluid can maintain a magnetic field. All right. Um, so basically, the Earth is a giant metallic landmass, I guess, and because of the motion um, around the sun, it and also the motion, the rotation of the Earth creates the magnetic field, like how iron could be converted into magnet temporarily. I mean, that's the whole principle of how motor works, right? Machine works. Uh, I'm kind of curious. Is exactly what exactly is magnet? If I can go to a Wikipedia page for magnet from somewhere here. Okay, Earth's magnetic field, predominantly dipolar at its surface, is distorted further out by the solar wind. This is a stream of charged particles leaving the sun's corona. The corona is the outermost layer of a star's atmosphere. They are made up of plasma. Okay, so this is a stream of charged particles leaving sun's corona and accelerating to a speed of 200 to 1000 kilometers per second. They carry with them a magnetic field, the interplanetary magnetic field. Now we're talking something at solar system level. The interplanetary magnetic field, now more commonly referred to as heliospheric magnetic field, is the component of the solar magnetic field that is dragged out from the solar corona by the solar wind flow to fill the solar system. Okay. A video simulation of Earth's magnetic field interacting with the solar interplanetary magnetic field. Whoa. Of course, it's coming from sun, but are there is there an influence from planets? From solar plasma. Why does it says interplanetary if it doesn't comprise of planets? Let's see if we can go to the magnet. A magnetic field is a vector field that describes the magnetic influence on moving electric charges, electric currents, and magnetic material. A moving charge is in a magnetic field experiences a force perpendicular to its own velocity and to the magnetic field. A permanent magnet's magnetic field pulls on ferromagnetic materials such as iron and attracts or repels other magnets. In addition, a magnetic field that varies with location will exert a force on range of non-magnetic materials by affecting the motion of their outer atomic electrons. Magnetic fields surround magnetized materials and are created by electric currents such as those used in electromagnets and by electric fields varying in time. At this point, it feels like I'm just reading it out loud, but aren't magnets fascinating? It is one of the natural force, right? In addition to um, electricity, gravitational. What are the other primary forces? Electromagnetic. I guess it's not magnetic, but it's electromagnetic. Just like how space time is kind of like embedded together. Uh, yeah, I think it's about time that I have to go to a comedy show. So I'm gonna wrap this up and I'm gonna get the hell out of here. It's gonna be 15-20 minute drive and the show starts at 1 a.m., which is the best part. It's called 1 a.m. show. Yeah, very creative. And it is one of the good, I would say, like, good room in Atlanta, and they have like booked comics there, and unfortunately, I'm not gonna perform there. Unfortunately for the people, of course, uh, but that's a good room. I'm every time I go there, I see like really good comics, who've been you know been doing this for a long time and amazingly well. So just watching them is kind of nice, and it's also kind of good change instead of like sitting here and going through Wikipedia pages. I guess. That's how I spent my weekend. Try to go to a comedy show and and listen to random funny thoughts from different comics, and I hope people find their type of comedy on whatever platforms that they use, because I think in the current time where there is so much pain, so much suffering, um, laughter is the only way to ease that out and keep moving forward, because as a lot of people said, what doesn't kill you make you stronger. And the more we continue to uh, move forward, the stronger we become. And That's why I am gonna move forward and go to that show and get get to see other comics perform. I'll talk to you guys. I'll talk to you. I'll do this again tomorrow, hopefully. Until then.